Hey guys, welcome back to the channel. In this video, we are going to discuss a very powerful concept in Golang and I would say in any other programming language, that is interfaces. So Golang actually derives only one concept from Java, a language that I really hate, is interfaces. So we don't need any abstract classes or things like that because Golang is not an object oriented programming language. The creators knew that we don't need an object oriented programming language in the first place. So they derived only one concept from other languages, and that is interfaces. And I would say that is an absolutely fantastic concept or theory which allows us to write much better code using the solid principles. So in this video, we are going to discuss the same thing. Let's go ahead and start coding. So I will be creating two shapes that are squares and rectangles. A square is a struct with a single side, while a rectangle is a struct with two sides which are length and breadth of the rectangle. Now I will write a function called area which is going to compute the area of the square, and as we all know, the area is simply side cross side. In case of rectangle, it is length cross breadth. Now since the functions cannot have the same name since they are taking in different parameters, we will rename the functions as area of square and area of rectangle. So our function implementation is complete. Now in the main function, I will go ahead and write square which has a single side of length 2, while a rectangle has two sides of length 2 and 3. Now area of rectangle will give us the area of rectangle which is 2 cross 3 which is 6, and in case of square it would be 2 cross 2 which is 4. We would go ahead and print this and run this program on the terminal. I would just add a tab for better readability, and as you can see, the answer is that for rectangle the area is 6 and for square it is 4. Well, I guess you can see the problem here. We have two different functions, area of square and area of rectangle, to compute the area of square and rectangle respectively. Now this I don't think is very good programming practice because our function is doing the same thing but it is doing for two different structs. So the idea is that can we make this better? Can we have a single function that computes the area of any kind of shape that you give it? Well, the answer is we can. And there's a very handy feature in Golang that we can say we can pass a type any, which is also a short form for type interface, to a function called area. So I will go ahead and start writing a new function, a single function called area, which takes an I, which is of type any. Any is any interface, so it can be anything. But now what we are going to do is we are going to use a switch case here. So switch case is kind of a type inference in Go, where we actually try to find what is the actual type of the interface. Is it a type square or is it a type rectangle? Or it can be default, like it is neither of the two. So in case if it is a square, we would go ahead and print the area, or return the area of the square, which is v dot side cross v dot side. In case of a rectangle, we would return v dot breadth cross v dot length. You can see the v that we got after doing I dot type is the inferred type. So it can either be square if we are checking it against a square, which is case square, or it will be converted to a rectangle when we are checking it against rectangle. In case of default, when we don't have any of the two, we would simply panic that the case is not implemented. So if you pass here, let's say an integer, it would say that the function is not implemented for integer. Well, you can see that the program works as expected. Now let's try to make this program even better. The thing is that when we are passing any, we are kind of declaring that, hey, you can pass anything here. It can be integer, it can be string, it can be any other custom data type or any other struct. But that is not what we want. We want something more specific. So let's go ahead and create an interface called area. Area is an interface which has only one function, that is area. which returns the area of any type that it is implemented for. So the idea of interfaces is that they are just a group of functions that should be implemented by a type for those types to implement that interface. This is very useful because when we do that, we actually declare that this type implements the interface. So now instead of passing type any, which is like any kind of interface, we are passing a type which implements a specific interface, which is in this case area. So now I will go ahead and implement that. I will create a new file interface where I will be writing the interface area. Then instead of any, I would go ahead and pass area interface. Now instead of writing all that logic, we can simply call a.area, which is going to return the area of the object. So the function area is going to call the function of the object which also implements the area interface underneath the hood. So inside area function, we are simply calling the area method of the interface that is being passed to it. Now you can see that it is not defined. So I would just go ahead and refactor this code a bit. I would instead create a module called shapes where I would be defining rectangle and square. I would also go ahead and initialize this as a Go module, which I did not do before. And as I keep saying in all of my videos, it is always a good practice to initialize a Go module. So Go mod init is completed. I have created a folder called shapes where I have defined interface, the general interface, the rectangle which implements that interface, and the square struct which also implements the interface. So you can see that now we are importing square and rectangle from the shapes package. The problem here now is that the side, length and breadth, all these feeds start with small case, which is a problem. It means that the shapes package doesn't export these values. So what we are going to do is we will just capitalize them. So small side would now become capital side, small length would be capital length, and we will also capitalize B for breadth. So now this should work. Now when we run the program, we get that area is not defined. So we would just go ahead and also move that inside interface and also export that from there. Now as you can see, the program is working as expected. So rectangle's area is again 6 and square's area is again 4. Let's go ahead and summarize what we have done till now. Initially we started with two different functions, and each function was trying to return the area of different types of shapes. Now this was not at all feasible, because in the future when we go ahead and implement more shapes, we would have to implement a separate function for each and every one of them, which is not a very good practice. So what we did was we implemented a single function called area, but as you could have seen, the function was too long. Now it was implementing a switch case for each and every kind of a shape, which was still better than before implementing different functions for different shapes, but it was still not good. Why? Because first of all, it is not at all testable. You cannot test it for each and every functionality, or maybe you can, but you cannot use those shapes. Like there is no mechanism to provide a proper dependency injection. So that is not a very good practice. And secondly, what we did was we have now migrated all the functionality inside the function. So our function is responsible for getting extended for different types of shapes. So in the future, let's say that some programmer who is new to the team and the code base is very large, they implement a different shape, but now inside this function, they will have to remember that I need to implement a switch case for this inside the function. And what if they mess up some other implementation inside the function? So some other shapes area would be wrong. So that is one of the reason why we need unit test cases for functions like these. But yeah, that is a separate topic to be discussed in another video. But coming back to the video, so you can see the problem here. Now, instead of implementing things on the side of the shape, we need to bring it on the side of the function and implement it there, which is again not a very good practice. What we want is, we want our structs to be extensible. So we want them to implement something which is common to each and every one of them, and that something is being called inside this function. It is kind of a ports and adapter pattern. So that is what interfaces are basically. What you want is an adapter, which in this case is the area interface. So any port or any object that needs to implement that interface would simply implement those functions which are part of the interface. Now, that struct is qualified to be called as an interface. So that struct is actually an interface. It has all the implementations of that interface. Now you can simply pass that interface inside a function, inside a test, or anywhere you want. So this also gives proper dependency injection primitives in Go or in any other programming language for that case. And here in our case, now the function is extensible. If you define another shape, let's say that in this case we are defining circle, we can simply go ahead and implement the area function for circle, and now we can also pass circle inside this function area, and it will work perfectly. So that is how interfaces work, and that is the proper way to code this. So I will just go ahead and write this. I've written this circle object, and I'm just doing some refactoring, trying to make it float instead of uint, because circle has that pi parameter for computing the area. So now I have, instead of making that specific circle return a float, I will be returning float for each and every kind of an area. So whether it is like decimal or it is integer, it will return a proper area in each and every case. So after the refactoring, I have also printed it prettily on the terminal with like 0.2f accuracy. So it will just print like two decimals, two numbers after the decimal point. Yeah, so this is it. And as you can see that this works perfectly, and our code is quite extensible. And given the fact that we started from having different functions for different shapes, we have come a long way. We implemented a single function, but even that was not the best kind of an implementation. So what we did was we made that function extensible. If you want to be called inside the function, you just need to implement this interface. So whenever a new programmer comes here, they implement a different shape, they just have to implement this interface to be able to be called by this function. So guys, this is it for this video. I hope you liked it. So happy coding. If you liked the video, then consider subscribing to the channel. In the future, I will be making more such informative videos with hands-on tutorials in the same monotonous voice. So thank you and see you next time.